This is the second lecture of Chapter 2 on Science, Matter, and Energy. Today we're going to talk about systems. A system is a set of components that interact in a regular or a predicted way. There are three main components: inputs, throughputs, and then the output. You can think of a car as a system. The input is gasoline, throughputs the combustion of the gasoline, and the output is the car moving. I want to talk about two main types of systems today. These systems are called feedback loops. There are positive and negative feedback loops. Feedback loops are where the output of a system becomes the input again. If the output that goes back in causes a change in the same direction, it's called a positive feedback loop. This type of feedback loop amplifies the output of the system, makes it bigger and bigger and bigger. An example of a positive feedback loop is the human population. The bigger it gets, the more people there are to have children, which makes the population even bigger. So it's like a vicious cycle. Positive doesn't necessarily mean it's a good thing. It just means it's driving, it's amplifying the system. If a feedback loop causes a change in the opposite direction, it's called a negative feedback loop. This type of feedback loop pushes the system back to its original state. An example of that: we burn fossil fuels that puts carbon dioxide into the air, and then plants absorb carbon dioxide in order to photosynthesize. That helps bring down the carbon dioxide level and return the level of carbon dioxide into the atmosphere to its normal state. That would be a negative feedback loop. It's returning to its original state, lessening the effect of the system. A time delay is the amount of time between the input and the response to it. If the time delay is too long, a system may cross a threshold level and no longer be able to be repaired. It might pass a tipping point where we can't push it back to its original state. Scientists believe we have almost reached this tipping point with global climate change. We keep putting more carbon dioxide into the atmosphere, which causes the Earth to warm. As a result, glaciers are melting, releasing more carbon dioxide into the air and decreasing their cooling effect on the Earth. There are also fewer plants on the planet due to habitat destruction to absorb the carbon dioxide. Scientists think that we've gotten close to the tipping point, that we can't reverse this process of the Earth warming. Okay, a few more examples of feedback loops. Let's suppose improvements in medicine lead to less infant mortality. More grow into adulthood and have children of their own. That's an example I gave you in the last slide. That's positive feedback. The population increases, so it amplifies the situation. Another example: your body temperature rises above 99 degrees Fahrenheit. You begin to sweat. That's a negative feedback loop because your body is trying to restore your system to a normal temperature. Another example: you receive an email chain letter. You send it on to 5 friends. They each send it on to 5 friends. That's another positive feedback loop. The number of letter recipients increases, so the system is amplified, gets bigger and bigger. Okay, let's see how one thing leads to another in these feedback loops. Your body temperature rises and you start to sweat. We already said that's a negative feedback loop. The sweat doesn't evaporate fast enough to cool you enough, and your temperature rises even more. Your body starts to work harder in producing sweat, and this causes your temperature to rise even more. That's a positive feedback loop, amplifying the situation. This can lead to heat stroke and even death. That would be an example of what? A tipping point. It's gone too far, and you can't reverse the process. Another example: Easter Island. Easter Island was a civilization based on the huge number and type of trees on the island. The population of the island increased as trees were used for shelter, tools, boats, and to move huge statues that were on the island. That was positive feedback, the population increase. Trees were cut down faster than they could grow back. Again, positive feedback, tree number continues to decrease. When the trees were gone, the population decreased until it was gone. Negative feedback loop. They reached a tipping point. The population grew and grew. They cut down trees faster and faster, which led to the system crash, the tipping point. Synergy is the term that we use to describe the whole is greater than the sum of the parts. So feedback loops work in a synergistic way, sometimes to reach those tipping points. Synergy is two or more processes that interact, and the combined effect is greater than the sum of their separate effects. An example, two people can each lift 100 pounds by themselves, but working together they can lift 270 pounds, not 200, not double what each individual could lift. That's synergy. Another example, two separate politicians can each get 1,000,000 votes, but working together they can appeal to 2.5 million voters. An environmental example of synergy is air pollution. We can put air pollution into the air from car exhaust, from industry, and what can happen is those pollutants that can get into the air can combine to form a whole new beast. So the whole is greater than the sum of the parts. The whole being the new beast that's created from the chemical combination of different types of air pollutants can be worse for you health-wise than just the individual parts of the air pollution. The butterfly effect when it comes to systems, or also called chaos theory. You can never change just one thing. Whatever you do has impacts on multiple other parts. Systems are too complex to fully predict all outcomes of any given action. A simplistic example of this, think of an ecosystem and all of the animals in ecosystem that rely on each other for their food sources. Let's say all of the rabbits in an ecosystem go extinct. Now, what are all the possible effects that could have on the ecosystem? The ecosystem is very complex. The rabbits ate grass. The grass could start to grow out of control. The hawks might have relied on the rabbits for food. There are probably many, many other impacts that removing rabbits from the ecosystem would have. So you can't change just one thing. Changing one thing in a system is going to have multiple unpredictable effects. Another example is the Jenga game. You know, those tall wooden blocks where you remove one at a time until whoever removes the one who makes it fall loses. You remove one block, but other tiny changes take place in that block tower. Eventually, one small change leads to an entire collapse. Today we learned about feedback loops, positive and negative, synergy, and the butterfly effect. Your assignment, I gave you A Sound of Thunder in class by Ray Bradbury. Read that and write a 1 to 2 paragraph of reflection on the butterfly effect from the story and how it relates to our lives today.